Hi everyone. Um, this is going to be our ResNet Paper review. It's hosted on Discord if anyone wants to join. We start it up now. Okay. What's up, Darkashura? How you doing?
Hello, I'm fine. What about you?
Can you hear me?
Yeah, yeah. Are you able to hear me?
Um, sort of. I might need to change to my AirPods because sometimes my computer speakers
Am
don't
I
work so well.
audible right now?
Okay.
Yeah, audible?
Yeah, yeah, I can hear you now.
Yeah,
Okay, I
I was.
mean,
Uh,
go ahead.
yeah, fine. What about you?
Doing good. Um, Doing good. I mean, it looks like it
Is it
might just be
morning?
me and you. Oh yeah, how's your day so
Yeah,
far? Like it's
yeah. I
nighttime by you, right?
think. Yeah, it's night time here. It's morning over your side, right?
Yeah,
Is it Monday morning or Sunday morning?
it's Sunday morning. For you, I guess it's Sunday
Oh,
night.
yeah,
This one
yeah,
I'm recording this, I guess, paper review. Might just be me and you though, which I'm okay with.
yeah.
Um, oh, first, what are your thoughts? Did you have time to try out? the deep deep ML
Labs.
labs. Yeah.
I was not able to try out, but like I saw it like when you posted it. I saw it during that time,
Okay.
and yeah, it was good. Like to try to implement things on my own. That was good thing.
Yeah. I came up with a new question.
Uh,
Now I need to work out the. Okay, we got. I feel like it's usually us three. We'll see if anyone else joins.
Hello
Um,
guys,
hey, what's up?
Hello.
doing fine. What about you guys?
Doing good. We're talking a little bit about
Uh,
the deep ML labs. I've
The
seen.
labs.
Oh yeah, how's the DeepML Labs going?
It's going. Did you have a chance to try it out or not
Yeah,
yet?
I did try one question so far.
Nice.
I am going to try others, but it is nice.
Okay.
Um, sort of using like instead of using like NumPy, sort of just using Torch.
Yeah, I
Yeah,
think
it's nice.
one of the questions only allows NumPy, but some and some. There's a little more
Hmm.
practical version of, and a little more
Yeah, it.
competitive in my mind.
Did you um last I checked there was like 4 questions, so there's more questions now
Not yet.
or
So,
not? Right? Okay.
yeah. But I had this idea for another question that I'm currently working on, but I think I might need, like, currently we don't use any GPUs, it's just all done on like CPU backends. But
Okay.
this
Nice.
question would have to do with ResNet, so basically it would be you're given a network with, I guess this is how we'll get into the ResNet talk, but you're basically given a network that has, let's say, 5 CNN layers, but that's it. So the depth is like 5. Uh, it'll run through and get your results, but those results probably won't be great. And
Mm-hmm.
and then your goal is basically keeping the depth the same, try and make the model have a better accuracy. I don't know what the accuracy would be, but something like that. So this way, people get to sort of figure out ResNet for themselves, or they could come up with a different architecture, or just dealing with that whole depth issue.
Sorry, which question was that for?
So I don't. It's one I'm working on for the labs.
Oh, okay, I see. Yeah,
Yeah, I need to
it's
have
a
a
ResNet
GPU.
related question.
So it would basically be, I guess your starter code would be, you would have a model, say this is CNN, and you'd have like, let's say, you'd have a bunch of CNNs, nothing between them,
Mm,
uh, and then a final result. It would be for fashion MNIST or MNIST or whatever it would be, and it would be very deep. Um, and this probably will make the model not have great results because it's so deep, like something will get lost in between it. And the user's goal is going to be to try and edit this model. So either you could use like the residual, uh, I guess, parameter, or you could use batch normalization and whatever you want to use to just try to make this model better. But one of the constraints is it has to be at least 5 or 4 depth-wise, CNN depth-wise.
oh, okay, cool. I see.
Yeah, so this way, like, in my mind, it's mimicking the scenarios that I guess the people that were creating ResNet were trying to solve, and this way you sort of try to
Mm.
solve that issue by yourself.
Oh, okay, that's nice.
But yeah, let's get to the paper review. Anyone else have any comments or thoughts? Okay. Um, so this week we read do ResNet, and I feel like it's a very interesting paper. I mean, so it was done on the ImageNet dataset, which is we've been talking about for the past few weeks, which is basically a bunch of images, and you're trying to classify them into one of 1,000 classes. Um, ResNet, I guess their whole question was, it seems like in all of the past papers, like AlexNet and GoogleNet, and basically almost every paper until now, the deeper the paper, the deeper the architecture, So if I have something with 10, like, VGG was just 16 CNN layers or whatever it was, and they had certain things to try and deal with certain aspects. But they basically had a very deep network, and that was seeming to give better and better results. So I guess ResNet's thought process, okay, but like, at what point does this break down, and why does it break down? So they wanted to see, I mean, I think some of the basic things they spoke about, they're like, okay, maybe it's the vanishing gradient issue. Because, if it's very deep, eventually the gradients will vanish. But that was dealt with by batch normalization. So if you do batch normalization, the gradient, disappearing gradient shouldn't be the issue. So like, okay, so it's not vanishing gradient. That's not like the issue with the higher amounts of depth. The cool thing I think they did, let's see if I could draw something quickly, was they basically had a network. It's not going to be as quick as that. They basically had a network. Whatever. You know what I'm trying to draw, just a basic neural network. Um, they basically had a network that had good results. So they trained a network that had decent results, and then they're like, okay, let's see how depth. Uh, so this is the beginning of the network, and then they trained it a bunch, and then they get an output. Let's do this for an output. These were like the good weights. Good weights. And their thought process was, let's see how depth affects this by adding. So this is good. Let's just add a bunch of, you know, just another set of weight classes or more trainable parameters. So just more neurons. So this is like more depth to it. And theoretically, if you go down this process, all it should do is just create the identity, or better, it just needs to create the identity and get these answers that are already in the model. But apparently, just adding depth to it, so just adding more and more layers to the model, made the results worse. So from here, they learn like, okay, there's obviously an issue. Yeah, the issue is not coming from overfitting. It's not coming from, you know, I think they actually had a picture for the overfitting issue. Yeah. So here they're like, okay, it's not coming from overfitting as well. I'm sort of jumping all over the place a little, but
Oh, your voice got cut.
oh, got cut up. Can you hear me now? Hello? Can you hear me or no? Hello?
I can hear you.
Oh, you can. Okay. Um,
Hello?
I can hear you too.
Oh, okay.
Maybe Darko Shore is having an issue.
Darkest Sewer, can you hear us?
Yeah, yeah. Now I can hear you.
Okay.
Oh, was
Can
it
you
a
hear?
problem from my side?
I think so. Can you hear
Correct.
me as well?
Yeah. Yeah.
Okay.
Sorry, sorry, sorry.
Okay, cool.
Um, so they also tested out maybe, the more layers you have, you're just overfitting. So the way they test this, they're like, okay, let's have a model with 56 layers and a model with 20 layers and look at the training error. But if it was overfitting, the training error for the 56 layers we should have less error, not more. So this was another instance of showing like, hey, okay, it's like there's an issue when things get too deep. Um, so I guess, there's the whole paper, their whole idea was basically to have a residual block, which is, uh, let me look at their image. Sorry. Um, basically have this. This was their whole idea. Basically to help the model remember, like it doesn't lose track of anything. So you will have weighted layers, ReLU, another weighted layer, and then it will be added back, like the original input to the model is going to be added back to the new processed information. This way it's not forgetting what it originally had. And then, they basically trained this model. I think they have a huge image version of it. Um, and they basically trained this, and it got really good results and it has the same, I think, this had the same complexity as like VGG19. Yeah, no, less. So this used 19 billion flops. Yeah, they used 3.6 billion flops, so it's less than the VGG19, and it got significantly better results. And it was all just thanks to this, this skip thing, this residual. I forgot what the term was, but thanks to just this little skip that they do, or not skip, but joining things back together, residual learning. Yeah. Yeah. So anyone have any thoughts about the paper? I know I just did a quick overview. We could talk about anything in more detail, or if anyone has any thoughts, or yeah. I wasn't sharing my screen. I feel bad. I was drawing here. That's my bad. I was drawing this stuff. Made more sense with the commentary, but anyone have any questions or thoughts? Um, I feel like I wonder. I guess I'll start with a question. Is this architecture used in like LLMs and stuff? Like, is this a similar issue that other large models face? And if so, would this help? And is it actually used? Does anyone know?
No, you are asking that if we can use this kind of architecture in LLMs.
I'm wondering if like a similar concept is used with LLM. Like, do LLMs face a similar issue? Because I know the LLM models are ginormous. So I wonder, is this a
Uh,
issue with their depth? And if so, do they use something similar?
I've never read the architecture, but I think the this architecture was good, right? For kind of keeping track of the older versions of older the content that is learned by the older layers, right, like you said.
Yeah,
So yeah, I think they might use this thing,
yeah.
but
I
uh,
know.
no idea about that.
I know, me too. I'm just curious if anyone knew, because I feel like it would be interesting. I feel like it'll also be interesting as we go through, I guess, newer and newer stuff. If we'll see like concepts from ResNet or concepts from AlexNet or anything like seep its way into more modern stuff. Um, I
Yeah.
think yeah. Um, I think next week we're gonna do the attention paper, which ought to be fun. Did anyone? I didn't think I solved it. Did anyone solve the ResNet collection?
I did, yeah.
Oh, nice. What'd you think about it?
It was cool. It did help me um sort of understand parts a little better. So sort of just like implement it a little more. But yeah, no, it was a nice collection.
Okay, cool. Yeah, because I feel like I guess in my mind, after reading a paper, it's sometimes hard. Or yeah, after reading a paper or before reading a paper, I feel like a collection would be nice to do. Because if you do all this, you probably could read a paper and be like, okay, I understand all the technical aspects about this. Um, that's my goal with the collection. Or you could read it after and make sure you actually understood everything on a deeper level and able to program it. Um, yeah, but it's also funny seeing like global average pooling. I'm pretty sure they also did that, but I think that was originally done with the GoogleNet paper. I think that was the first time it showed up, and then I guess that's how the research is done. Is like you steal a little from the past and implement something new. Uh, I wonder what today's cutting edge is. Let me ask chat. Best, best deep learning. I wonder what's the best. You know, have they made better advancements in the last, I don't know, 10 years. Um, Looks like going for good accuracy, but unstable. Is it this one? I guess this one, I
I'm
guess.
not getting your voice clearly
Oh,
right now.
sorry. Can you hear me now or no?
Yeah,
Okay, sorry. um, let's see. I was just looking to see what would be the best, like what's the current state of the art in terms of, they used to have papers with code that used to just have this information, but I think they stopped using it or stopped keeping it up to date. Um, I guess I'm just curious, like, what's the state of the art for ImageNet right now or image classification? Let me just ask what it is.
like for most of the cases right now, matlab, LLMs or transformers are the state of the art. Matlab, up until what I know. At the end of the day, whether it's like whatever you want to build, it's like okay, LLM can do this task, LLM can do that task.
I'm always curious to know, like, how good is an LLM at just text classification versus a model that's specifically trained? Let's say, like a spam, not spam model. Like, I train it specifically for spam, not spam. Or I use an LLM for spam, not spam. Like, basically say, hey, is this spam or not? I wonder which one would have better classification results. Like, is there a point of you ever training a model for spam or not spam, or is it just always better to use an LLM? Um,
No idea. But but if you think about it, say if you want to build a spam no spam classifier, right?
Mhm.
The LLM is kind of an overkill for that. It's kind of using a way too complex model to solve a way too simple problem.
Yeah, but I guess let's say a company doesn't want to hire a data scientist, and they're just like, okay, let me just use an API call to OpenAI, the simplest, like
Yeah,
their smallest model, and now I have a spam not spam filter. But I
classifier.
guess it is probably a
Yeah.
lot more expensive to constantly run in production because then
Hmm.
every time you're using more and more tokens versus if it's just a model hosted, it's pretty cheap. But I do wonder that in like how I mean I guess at some point it would break down. Like if I took the Titanic data set and gave it all of the information and I asked, hey, do you think this person survived or didn't survive on the Titanic given this information? I feel like a random forest model would do a better job than an LLM. Maybe I'm wrong, but that's an interesting question. I was thinking about making a library just for like simplify the process of using a LLM for classification. I think that would be cool. I wonder if anyone ever did that.
This
Um,
kind of uh, by library you mean like having these built-in functions for for these particular data sets, right?
yeah, so just for like I guess you choose which classes you want, and then it uses an LLM in the background to just choose the class, and also probably could give you a probability of each class, given basically probability of the next token being each one of your classes, and lets you know like, oh hey, it's probably one of these. Hmm. I wonder, like, let's say you use an LLM as like I guess like you try to fine tune something using an LLM. So first you train, let's say you don't have a lot of data for something, uh, like the spam not spam filter. So let's say you start with I guess the results from ChatGPT. So you have ChatGPT make like let's say you have a lot of unlabeled data, so you use ChatGPT to label it, you train the model on that, and then you fine tune it on your small labeled data set. I wonder, that'd probably do pretty well. But just a thought. Okay. Anyone else have any thoughts or just want to chat about something machine learning related? Okay. Take that as a no. I guess next week we'll do
No, like
potentially. Go ahead.
like l- uh, let me just kind of phrase it out. Yeah, so like you know, when you kind of like say you pick an algorithm, you work on that algorithm, and then at some point of time, it's like, okay, but I know what this algorithm does, and that's it. Like that's the working part of this theorem. But
Mhm.
most of the time, it's like, why did we learn this kind of algorithm? Or like, there's no use for that particular algorithm. So,
Mhm.
मतलब, what should we do about that? मतलब, it's
You saying
kind of,
on DeepML, like basically we're like, hey, implement this random algorithm. What's the point to an extent?
yeah,
Is
like, think about it. Like, for example, let's take a simple algorithm, say decision tree. So you learned about it, and you know like how to implement or what kind of working it has. But like after that, what? Like it's
mhm. I
the
don't know. That's a
it's
yeah.
not like
No, I definitely thought about it. And it's a good question. I mean, there's a few reasons in my mind. Let me know what you think. One is, I guess, if you're trying to come up with something new, you should probably understand the old stuff, or you're trying to make something better, you probably should understand the inner workings of like you should understand the inner workings. Like if you're trying to make a better model and you're doing research, you should probably understand everything, um, all the essentials and all the information. Also, I think knowing how things really work, you also know where the pitfalls are. And I think in the world of, LLMs and people being like, oh, hey, you could just use an LLM and it'll tell you which model to use and it'll tell you which things. Like, if you don't know how these things actually work, you're probably not gonna be able to spot the issues with, like, everyone's gonna use ChatGPT, but you won't be able to spot the issues with, oh, it told me to use random forest with this depth, with this whatever. And if you're just like, sure, whatever, you're probably gonna have a suboptimal model, or there could be hallucinations in there. But like, if someone doesn't know how the models actually work, they sort of just implement anything, and some things will break, and they don't know why it broke. And I guess that's my 2 cents about it. Let me know your thoughts.
but yeah, like I understand what you're trying to say. And agreed that okay, you should know about what has happened in these past you can say it's not exactly a past thing because it's only it's only in recent 2 or 3 years that deep learning has taken that kind of boom or something. But yeah, like if you think about it right now, like, I'm not sure because but what I have seen, like the traditional ML algorithms, like they are not they are not in that much use, right?
Hmm.
Uh, I might be wrong about that, but
Um,
at least what I have seen, the,
I mean, on Kaggle they're used a
I've not
lot, but
seen. Yeah, yeah.
yeah, Kaggle they usually really like. What is it? Random, not random forest. XGBoost is like wins most of the competitions. Deep learning, I feel like works very well for like very in like things with a lot of data, but things with like a medium amount of data or a small amount of data. I think machine learning has a little bit of an edge, and it's a little easier to train as well. At least based on my experience,
Yeah,
and I feel
'cause
like Kaggle competitions. Like with ImageNet, it works well
I think
because images are huge and there's a lot of information.
yeah, but if you think about it, so uh, uh, tradition, uh, the XG boost as well in most of the Kaggle competitions as well. It's always XG boost or maybe neural nets at the end of the day that
Yeah.
people implement. Like most of the times, whenever I kind of try to participate in a competition or kind of try to learn like the method that they are using to solve the particular problem statement, most of the time it's either XGBoost or say some one or two other methods as well. But in the current times, for anything, like even if you want to make uh, even the even if you want to make first of all the things that people right now want to make are some things which are kind of not easily um, they can't be easily made using ML algorithms, right? Like most of the time, it's deep learning algorithms because now people have more and more and more data sets, right? So isn't it kind of, you can say,
Like,
ML, reaching the end of ML
I mean, I do, in my mind,
or
it's
something?
also, I guess, deep learning is within, I mean, yeah, deep learning is within machine learning. Like, in my mind, machine learning is the big circle, and then deep learning is within there. But you're saying like classical machine learning. I mean, there's always going to, in my mind at least, there's always going to be examples where you don't have so much data, or, I mean, XGBoost could probably get through most things. Like, is there a point of learning linear regression? Is there a point of doing random forest versus XGBoost? I don't think so. I mean, it's probably good to know these things and test them out, but yeah, at a certain level, a lot of them are deprecated, but it's still good to know so you understand the basics behind these things. But yeah, I agree with you to a certain extent. That there are some
Uh,
algorithms that is that what you're saying, or am I misunderstanding?
yeah, something along those lines as well. Um, now, it's not like what it used to be 10 years back down the line. Right, like during those times, like we read also in those other papers. So the GPUs, the GPUs were not sufficient in memory. They did not have sufficient memory storage. They were small, and not everyone used to have GPUs, right? But nowadays, every single person has GPU.
Hmm.
Most of the time, they have access to it. So it's like you said that spam classifier thing that you can use traditional ML or maybe you can use LLM. So even if you want to train, say, a neural net on spam classifier thingy, you can just the training time is less, the inference time is less, or everything, right? So
Yeah,
I
I mean,
was
I guess the
just
only use
thinking,
case I
but
can
yeah,
think for is in cases where, I mean, a lot of times I feel like people don't have a lot of labeled data or a lot of data in general. I mean, for big companies or, if you're working at like a bank or something where they have a lot of data and a lot of it's labeled, sure, but I guess probably with smaller companies, it's a little harder for them to gather so much data on everything. And you might need to make, like, I do think a linear regression model needs a lot less data to do a decent job than a neural net. Even though I guess a neural net could approximate linear regression at some point. But then it's a lot more tweaking and fine tuning versus an algorithm you know is going to work. But yeah, I guess, eh, I don't know, interesting. I feel like I'm figuring out my stance on these things while talking to you. I'm just like, I guess for small use cases or medium use cases, there still could be a place for machine learning. Because as far as I know, like neural networks are a little more finicky with smaller amounts of data. If you have a lot of data, it'll do well, but smaller amounts, it usually struggles.
Yeah,
I could be wrong about that, but I mean that's my current understanding about it. But yeah, it's definitely an interesting
yeah,
point. It's definitely an interesting
yeah,
point.
those are those.
Trying to think. Okay.
Yeah, and like this is from my side. So
Mhm.
just since you are a data scientist, I just wanted to ask like what kind of prep uh, you suggest on doing to get a role in data science and all.
In my mind, I guess it's split up into two parts. You have the getting an interview and you have passing the interview. Um, Getting the interview, I mean, I guess it's just building a good enough resume to get through some bots and reading the job description, try to use some of the same words they use in the job description in your resume. Be like, oh, I want my people to use this, this, and this, and you probably should be like, okay, I use this in term, I use PyTorch to develop this and that, um, just to get past some bots, and then ideally, I don't know, in my mind, when DeepML becomes more established, hopefully collections actually, like companies will be like, oh, this person has the dense net collection on their resume, and that shows that they
Mm,
know something. And that was sort of my idea with the
mm,
collections, because it's, I mean, DeepML is supposed to solve two issues. One, how do you know something? Like if you read something or you watch a video, you don't know how much of that you actually retained, but you could go and solve a question and actually be like, okay, I actually understood this because I got the test cases correct. And then the second question of how do you show it to companies? So in my ideal world, hopefully one day this is actually a thing, but people will put their collections on their LinkedIn or on their resume and be like, hey, because right now you can't just be like, hey, I read this paper. Like, where are you going to say that on your resume? You can't really, it's hard to
yeah,
bring up in an interview. But if you have like a badge saying, I know this, it's like,
yeah,
okay, it's something. It shows off. Because when I think to break into the field, I think it's annoying for no reason. Like, I think people that know their stuff don't usually get to the interviews even or get to. I mean, and then if they do get to the interview and they really know deep learning, and then they get to the interview and it's leak code based, and it's just like now I need to go back instead of becoming a better data scientist, I need to go back and become a better leak code solver, and then go through this process again, get an interview, take the leak code exam basically, and then go to an interview, and then they'll finally talk to me about machine learning. Eh, in my mind, it's a broken system. Our long-term goal is to try and fix this, but in the short term, I'd say, I mean, I guess you have to just try and hope that the bots let you through the system, do good on the leak code stuff, or the basic Python questions that they ask. Get to the interview. They'll either ask you a take-home, they'll give you a take-home test, or they'll give you just an interview and they'll ask you some machine learning questions. Um, but yeah, in my mind, I don't like the current system, and that's I guess why I'm trying to change it. But we'll see how that goes.
yeah.
Did that
Mm,
answer your
no,
question? I feel like I rambled for a while.
no, that's cool. Makes sense. Um, I guess like as of right now, are you aware of maybe anyone who's um sort of just use like these collections or badges and maybe it got brought up in like an interview or relevancy towards like the job search? Like, do you know anyone as of right now who
I probably
was
should take a survey,
who's
maybe
booked
send it
into?
to the users and see who. It's a good idea. Just see who put it on their LinkedIn and did help them get an interview or anything like that. Because some people have put it on their LinkedIn's, which or like at least see where they're working now and see when they put it on their LinkedIn. some sort of stats would be nice about it. But I mean, we have, yeah, our long-term vision is to fix you know, the interview process and just breaking into the machine learning field because I think in my mind right now, or you could, always go to college and spend an insane amount of money getting a master's degree, and that, it shows that you know something. I mean, it also might not be super relevant because the things you learn in college aren't that necessarily the things you're going to be using on your day-to-day job, but you know, and or you have the Coursera, whatever it's called. In my mind, I don't like those at all because I could just watch it on 3 times speed, get a certificate, don't listen to any of it, put it on my LinkedIn, and be like, hey, look, I know deep learning. It's just like that. I feel like it doesn't show anything. So yeah, um, in my mind, it's hopefully DeepMill could be a place where at some point we'll have a course, and at some point, hopefully the collections mean more. And I think as time goes on, people will be like, oh, someone has a DeepML certificate, and it's not just watching a video. It's actually solving something and learning something, and you have to prove yourself. Then I think, yeah, I don't want something that people could just cheat easily and it means nothing. It's a piece of paper. Like, if data scientists and people start respect, like, but then I also need to make something that people can't cheat easily. Um, yeah.
Yeah. Instead of just instead of just watching some tutorials or maybe just uh, reading some kind of theories or whatever. You are more towards the side of practical implementation, and
Yeah.
it's kind of good as well. Because if you think about it, only when you start implementing these things, you get the idea of how to implement, what to implement, when to particularly implement, or if you are given a problem, like how to tackle that problem. You can say develop that intuition thing. Like, okay, so this kind of problem, so this is the kind of direction that I should think about solving this problem, and this is how I should solve this problem.
Yeah.
Yeah.
Yeah, but I mean, it gets me, it gets me annoyed the current process, but I think, I really do think that, I'm gonna try my best to make this process better for everyone because I feel like I went through this, but like currently I'm a data scientist and I don't know, years of experience and whatever, but I feel like breaking into it is annoying. If I need to get a new job, it's annoying. And also, I hate spending time. I mean, I don't mind solving leak code questions. I just don't like the idea of, like, I could be spending my time becoming a better data scientist, but instead I need to focus on something that's not going to make me a better data scientist. And I guess that thought annoys me. Um, okay. Thank you guys for indulging me in my ranting.
Oh, yeah, I'm kind of relating. Your mission is good and your thought is also good only. Yeah. Uh, yeah, there are two things, like you said. Either try to become better in what you are doing, or just try to develop something which is worth doing. Yeah. Oh,
Yeah.
sweet
And,
game.
yeah. And then I feel like also some people feel like, oh, just contribute to open source, but I don't feel like companies. I mean, some companies do, and those are good companies, and but I feel like some of them just like, eh, they care if you went to this college or that college and got this degree or that degree, which in my mind doesn't. It's not the. I mean, it's an indicator, and I'm sure it gives some predictive ability on how good of a data scientist you are, but I feel like there's better predictors out there. I mean, I'm more. I got a bachelor's degree in statistics and quantitative modeling. I didn't get a master's. I'm more self-taught than I think most data scientists. Maybe I'm not. I mean, at some point, everyone has to become self-taught because the field just keeps growing and growing and growing.
Yeah,
Um,
that's true. Uh, I think like even these, even when you go to college or maybe even if you do masters and all, uh, all you get from those things are just a direction. Or for maybe say if you take a course, all you get is like what kind of content is in that course, and then at the end of the day, you still need to learn it on your own, like you said.
yeah, it's you learning ideas. But yeah, I think even from, in my mind, also from the company's standpoint, because then, I feel like it makes sense from the interviewee standpoint. Like, oh, hey, we should be tested on machine learning stuff because that's what we're studying. Um, but even from the employer standpoint, I'd imagine like if they get someone that's really good at leak code, they'll get through. They have a decent resume. They'll get through the first part, and then they'll have to interview them in person. And I say to start asking them some machine learning questions that they don't know so much machine learning. So they just wasted
Mm.
resources and getting this person here, and then this person has to interview them. They realize they don't know as much as they thought they knew, and then they have to keep this process up. And then maybe they missed out on some of the best talent in the beginning because they either didn't have a good resume or they didn't know leak code. So in my mind, it'll be improving their process as well. But no,
But I
yeah,
think in recent times, companies have started to shift more over ML questions only, right? For job roles like data scientists or
it's
machine learning
start.
engineers.
It's starting to, but a lot of the questions are also like just, in my experience, it's either SQL, like you'll get a one SQL question, that's usually
Yeah,
also, and then
yeah,
you'll get some multiple choice question. I mean, at least for me, I was getting some multiple choice machine learning questions, nothing.
yeah.
And then usually I also get at least one like easy or medium leak code question. So it feels like it's a little bit of everything now, which is progress, but I think we could do better. Eventually, when I have an idea in mind that eventually we'll hopefully uh, broadcast and announce. Um, but I feel like that'll be in, we'll say 6 months if we get funding, probably less than that. But yeah, that's the goal of DeepML is fix this process.
Mm.
I mean, yeah, I feel like it's also a selfish thing because I'm just like I hate this process. Anyone have any thoughts or questions about anything else?
I think we said something in the chat.
Oh, let's see.
It's 5 minutes. I'll be home. Oh,
I didn't see the chat. Let me see. Um, None of the images are loading for me that someone sent, but oh, just 5 minutes. I'll be home in five. Oh, out of mentor right now. And we did the ResNet review already. We did it at I guess like 50 minutes ago.
yeah.
Yeah, and then we were just I mean, I was ranting for a little. I feel like this is the the paper reviews. We do like 20-30 minutes of paper review, and then it's just like 20-30 minutes of me ranting about something. But I appreciate you guys indulging me.
It's kind of fun. Just mm, giving this 1 hour of the day, of the week, and just kind of talk about papers and ideas and all and all.
Yeah, I agree. Okay. if nothing else, I guess next week we'll do attention is all you need. If anyone
Attention.
like, yeah, if anyone would like to present, I'm sorry, I didn't share my screen. I was doing, I guess, yeah, I just forgot to share my screen. But we'll do attention is all you need. If somebody would like to present, I guess write it in the chat or let me know. Uh,
Um, for the attention is all you need. I seen like there was like a collection, but that's also under like the premium section.
I'll make
Pro.
it free for the
So,
week.
oh, okay, cool.
Yeah, this way people have
Yeah,
to download.
that's what I was gonna say. Like if um it stays premium, would you make like maybe additional questions or like um slightly different questions
I mean,
on
the
those lines?
collections, all the collections are just collections of existing questions. Like all the questions are free. Like I don't like how LeetCode like gates off some of their questions. Everything's accessible, just collections make it easier. But yeah, I'll make the attention's all you need collection free to open to everyone for the week.
Oh, okay, cool. Thanks.
No problem. Uh, okay. Thank you everyone for your time. This was fun. Okay. I'll talk to you guys. Bye.
Yeah. Bye.
Okay, bye.